Hello, my name is Fariza and I have been a project manager at PIM for over a year. I work on low-carbon concrete topics, especially concretes made with calcined clay. The requirements needed for this job are knowledge about concrete, mainly in concrete formulation, concrete characterization, and the optimization and improvement of its properties. Our goal today is to reduce the carbon footprint of construction, and the first lever is to formulate concretes with a low carbon impact. Understanding the rheology of concrete is essential to ensure proper flow, workability, placement, and finishing of the final concrete. There are several factors that affect the rheology of fresh concrete, such as the composition of the concrete. It's important to keep in mind that adding water to the concrete mix can improve its fluidity and make placement easier, but ultimately it will degrade the mechanical properties of the hardened concrete. The second point is that the type of cement can also affect the rheology of fresh concrete. Attention must also be paid to the particle size distribution of the concrete and the choice of admixtures, which can improve the rheology of the concrete without adding water. I am working on the topic of concrete made with calcined clay. The ST3 technology will significantly reduce CO2 emissions, use abundant materials available worldwide, and ensure a rapid and effective transition to sustainable and responsible construction. The mixing room is an essential step in concrete formulation because if the mix design is not finalized, we cannot make test specimens afterwards and test the properties of the hardened concrete. Now, we are going to make a concrete mix which will consist of several steps. The first step is to mix the aggregates, that is the sand and gravel, in order to homogenize the granular skeleton and then pre-wet them. The second step is to add the binders, and after adding the binders, we will add the water, which will contain a portion of admixture. This will help improve the performance of the concrete in its fresh state. Here is the fresh concrete we obtained with this mix. The first thing we do is measure the temperature of the concrete. Slump test using the Abrams cone. This is a standard test that allows us to check the consistency of the concrete. The idea is to fill the Abrams cone in several layers, tamping each one, and then measure the slump to determine the consistency class of the concrete. Our goal for this concrete is to achieve a slump of 210 mm.